Suppose we have this situation where z is our dependent variable, and z is a function of x and y. Now, in most instances, x and y are independent of each other. They're not functionally related in most cases. But there are certain situations where y will be a function of x. So suppose we have this. Z is a function of x and y, and y is also a function of x. These situations occur sometimes where these two variables here are functionally related to each other. In this type of setup, you will have what's called a total derivative of z with respect to x. Because if you substitute in for y here, notice y is just a function of x. So we could write this as f equals a function of x, comma, g of x. So in essence, z can be expressed as a function of x alone. And you can find the derivative of z with respect to x. But let me show you how to do this in a slightly different way. Let's take this expression here. Z is a function of x and y. And let's just forget about this part. Oh, I don't want to erase this. We're still assuming y is a function of x. Let's take the total differential of z. The total differential of z will be exactly the same as before. What will the total differential be, Ben? If I may call on you. Yeah. But you don't mind, do you? You can take it. You got your coffee there.
Okay, so we're going to do dz equals.
Yes. Okay, partial z, either partial z or partial f, either one. Since Ben said z, I'll put partial z.
Over partial
X, yeah. Generally, you do this one first, Ben, because x comes first. Whatever comes first is what you generally do first. Exactly. Times dy, yes. Sometimes you have to speak up. My hearing is not as good as it used to be. Okay, that's the same expression. It's still true whether x and y are functionally related or not. But in this case here, we know that y is a function of x, so we could express z as a function of x. So we might be interested in dz dx. In order to get dz dx, the derivative of z with respect to x, notice this dz is a total differential. But if we want the derivative of z with respect to x, all we have to do is divide both sides of this equation by dx. Doing so, we get dz dx equals partial z partial x. Notice by dividing dx by dx, that's just 1. Plus partial z partial y dy dx. Okay. And this equation right here is called the total derivative of z with respect to x. Notice this total derivative has two components, partial z partial x This term right here is referred to as the direct effect. Okay, let me write this down. This is the direct effect. And clearly it's the direct effect of x on z, holding y constant, just the partial derivative. And that's called the direct effect. This term here is the indirect effect. It's the indirect effect of x on z, which is just the effect of x on y multiplied times the effect of y on z. Okay, and it's called the indirect effect. And this thing over here is called the total derivative.